Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover angle between two planes, angle between a line and a plane, and also point of intersection between a line and a plane. Okay, so first let's look at for angle between two planes. Alright, so let's say if we have two planes right here, okay, so this is a plane and here is another plane. Okay, so this plane will have a vector that is perpendicular to its surface. So this is vector n, and right here we also have another vector n that is perpendicular to the surface, a normal vector. Okay, so in order to calculate the angle between these two planes, so we will use the formula from the dot product, which the cosine theta. Yeah, let's say this is our n1, this is our n2. So n1 dot n2 divide magnitude of n1 and magnitude of n2. Okay, so which means the angle between the two planes can be determined by calculating the angle between the two normal vectors. Okay, now let's look at this example. We want to find the angle between these two planes of P1 and plane P2. Okay, so we are given with the equation of a plane for P1 and P2. So what we need to do with this equation is that to extract the value or extract the equation of a vector perpendicular to the plane of P1 and P2. So for P1, so the n1 will be equal to the I plus 3j plus k, and then for P2 the n2 is equal to 2i minus j plus 5k. Alright, so this is the n1 and n2 for P1 and P2. Then we can proceed to calculate the magnitude of n1 and n2. So magnitude of n1, 1 square, 3 square and 1 square, square root, and this is equal to square root of 11. Meanwhile for magnitude of n2, 2 square plus negative 1 square, 5 square. So this one is equal to square root of 30. Okay, so now we have the magnitude of n1 and n2, and now we calculate the dot product between n1 and n2. So 1, 2, 3, negative 1, 1, and 5. So for the dot product, it will be equal to 4. Okay, then we substitute this value into the equation of theta equal to cosine negative 1, 4 over square root of 11 and square root of 30. And by that, you will have the angle of theta equal to 77.3 degree. So that is the angle between the plane of P1 and plane P2. Okay, so next let's move on to the angle between a line and a plane. Okay, so for this one, let's say if we have a plane right here, so there is a line that is passing through the plane at an angle. So here is the line. Okay, and then from a plane, from that plane we know a plane will always has a vector that is perpendicular to its surface. So let's say this is the vector that coming out from the same point the plane intersect with the line. Okay, so in order to calculate the angle between the line and the plane, we can calculate the angle between the line with the vector n. So this is a theta. So this indicates the angle between the line and to the vector n. So you can just calculate the vector, the angle between the line to the plane by calculating this angle right down here, and by taking 90 degree minus theta, and then you will obtain the angle of theta. Okay, let's look at an example of question. Okay, so we are given with 3 points PQR, so on a plane. So we have to find the angle between the plane to the straight line of this equation. Okay, so from that, we are given with point P, Q, and R. So let's say this is point P, this is Q, and this is point R. So these 3 points will create a plane. Okay, so these 3 points will create a plane. So firstly, we have to determine the vector normal to this plane. Okay, so to find the vector normal to this plane is by calculating, firstly by finding the vector PQ and also vector PR. Okay, so then we have to do PQ cross PR, and then we will obtain the vector N. Okay, so from that, the vector of PQ will be equal to negative 2i plus 2j plus 2k. Okay, you can calculate that. You can find that equation from the given coordinates of P and coordinate of Q. Then for PR, that will be negative 3i minus j plus 3k. Alright, so now we have the vector for PQ and PR. So next is to do the cross product between PQ and PR. So we have start to ijk and negative 2, 2, 2, negative 3, negative 1, and 3. And it will be equal to I, negative 1, 1 plus 1, 2, 2, negative 1, 3, j, negative 1, 1 plus 2, negative 2, 2, negative 3, 3. Okay, so from that we now have the 6 plus 2i minus negative 6 plus 6j plus 2 plus 6k, and now we have 8i plus 8k. Alright, so this is the equation of the vector N that is perpendicular to the surface of the plane PQR. Okay, so now we have, from the equation we are given with the equation of the straight line, that is the R equal to I minus 2j plus 3k plus lambda 2i plus j minus k. Okay, don't worry about the lambda. So the lambda actually substitute the t that we used to use before. So from the equation of the straight line, the vector m from the straight line is right here. So this indicate the vector m. So this is the m equal to 2i plus j minus k. And we already have the vector n, that is 8i plus 8k. So next we have to find the angle in between the vector m and vector n. Okay, so we start with the magnitude m. Okay, so the magnitude of m is equal to square root of 6, and then magnitude of n is equal to square root of 128. Okay, so the angle between m and n is theta cosine negative 1 the dot product between m and n is 2, 8 plus negative 1, 8 over square root of 6 and square root of 1 to 8. And now we have the answer for theta is 73.2 degree. Okay, but 73.2 degree is not yet the answer that we are looking for. Okay, by the diagram, sorry, we have actually a triangle right here. Okay, by the diagram, okay, this is the line that passing through, and this one is the vector normal to the surface of the plane. Okay, so since we calculate, what we calculate is actually the angle between n and vector m that is parallel to the line. So that means the theta actually indicates the angle right over here, 73.2 degree. So the angle between the plane is actually the remaining of the 90 degree right over here. So to calculate that angle, we take 90 degree minus 73.2 degree, and now we have the answer is actually 16.7 degree. So that is our answer. Okay, so next section is about to find the point of intersection between a line and a plane. So given that the example here is to find the coordinate of the point of intersection between the straight line and the plane. Okay, so by the diagram, here we have a plane, and on the plane we have a line that is passing through the plane. So that is the line. Okay, so our task here is to find the point of intersection, which is the right here, and we are given with the equation of the straight line, r equal to minus k plus t I plus 2j plus k. Alright, and then we are also given with the equation of the plane, r dot equal to 13. Okay, so remember from my class, from my previous class, that I have mentioned about the point R. Okay, so we can assign that point R as the point of intersection between the line and the plane. So in order to find the coordinate of the point R, is we just have to solve for the R in the straight line, in the equation of the straight line. So that is the point of R. So in order to solve for that point of R, firstly we have to determine this value of t. Alright. Okay, so to determine that value of t, we take the equation of the straight line and we proceed with the addition between these two vectors. So where the r equal to I plus t I plus 2j plus k right here. And now if we proceed with the operation of addition between these two vectors, so we will have 2 plus t I plus 1 plus 2 tj plus negative 1 plus t k. Alright, so now we have this equation of r, and we now substitute this r into the r on the plane, because we can also assign the coordinate of r of the plane on the same spot of intersection. Okay, now we substitute, then we will have dot with 2i plus j minus 2 k equal to 13. Okay, so now we proceed with the operation of dot product, and we supposedly have 2 plus t, and then plus 1 plus 2t, and minus 2 negative 1 plus t equal to 13. And then we have 4 plus 2t plus 1 plus 2t plus 2 minus 2t equal to 13. Okay, then we have 2 plus 2 minus 2, then we have 2t, then 4, 1 plus 2 is equal to 7 equal to 13, then 2t is equal to 6, then t we have that is equal to 3. Okay, now we have the value of t. So then we just substitute back the value of t into the equation of the straight line right here. Okay, then we have r equal to, then here is the 3, sorry, should be 2j not 2t, and now we have the value of vector r is 5i plus 7j plus 2k. Alright, so from the equation of the vector of r, we can determine the position of the point r. So that is 5, 7, and 2. So this is the point coordinate where the intersection between the plane and the straight line occur.